Okay, example 3. This is a classic kind of problem to do with heights of trees or heights of houses or heights of buildings or flagpoles, etc. What we have here is from a point on the ground, 40 meters from the base of a tree, the angle of elevation of the top of the tree is 40 degrees. Calculate the height of the tree correct to the nearest meter. So I want you to imagine you're out on flat ground. Here's the ground. Here's a tree, and you want to know the height of the tree. So I could mark in the height as x. We want to figure out the height of the tree. But maybe you can't climb up the tree with a measuring tape, or so what you do instead is you go to the bottom of the tree and you walk back along the ground until you're 40 meters away or some distance away. In this question, it's 40 meters away. And maybe you lie down on the ground and you look up at the top of the tree and you measure the angle that you have to look up at. And you have to crane your neck and look up at 40 degrees in this question. So they're able to measure this angle 40 degrees. Okay. In fact, we've done this in the past with TY students outside in the yard using a thing called a clinometer. A clinometer measures angle. Okay, so you look up the top, it's 40 degrees. And just from knowing this distance and that angle, we can work out the height of the tree. So how do we do it? Well, you're looking for triangles. Can you see a triangle in the picture? And there actually is a triangle. If you could imagine a line from the top of the tree going straight down to the ground, then the line going across to where you are measuring your angle, and then this imaginary line going up at an angle. That forms a triangle. So let's draw the triangle on its own with no trees or ground or distractions. I can assume that this is a right angle. Why? Because we can imagine that the height is measured vertically up from the ground and the ground is flat, so this is 90 degrees. I know that the bottom of the triangle is 40 meters long, and I know this angle is 40 degrees, and then this height here is x. Now the question becomes find x, and this is a very straightforward question. We cannot use Pythagoras' theorem because we only know one side, so we have to use SOHCAHTOA. So let's label our triangle. If this is my right angle, this would be H. This is the angle I know, so this is O and this is A. I tick the one I want to know. I tick the one I know. Which one has O and A in it? It's tan. So I say tan of 40 degrees is O over A. So tan of 40 degrees is x over 40, because 40 meters. And then x is, to get rid of a divide by 40, you multiply. So it's 40 tan 40 degrees. And we can type that into a calculator. 40 tan 40 degrees, press equals, and I get 33.56 meters. Now, my answer is the height of the tree. They want it to their nearest meter. So the nearest meter means, is it 33 meters or is it closer to 34 meters? Well, look, it's 0.56, so it's closer to 34 meters. So this tree, from our measurements, would be 34 meters high. There are questions similar to this in your books.